All right, let's begin, right? We're going to start today by kind of taking a step back, right, and looking at the big picture of what we are talking about in this class when we're talking about biomedical instruments, and specifically biomedical instruments that are used for measurement. So here's a very cute kid. Don't worry, he is not sick. He's actually participating in a sleep study. Okay, it's my son. He went to a sleep study the other week. And I said, send me a picture. I'll use it in my class because I teach about this stuff. So here he is. The sensors were put on him and he spent the night. Mom was there too, right? Just to check about how well he's sleeping, right? He's fine. But I want to notice that he has all these measurement devices hooked up to him, right? The device under his nose is not to assist breathing. It's another sensor, all right? And you'll notice there's one sensor in particular here, and there's a wire running this way, all right? And the reason I wanted to show you this particular angle is I wanted to show you that you have all these sort of components, I'm already using the word sensors, that are on him, and yet there are all these wires coming off each one of those sensors running to another piece of equipment that you cannot see. Do the next slide. Okay. This is a pulse oximeter, all right, that you might see at a hospital, right? It comes on this little wheelie cart, and there you can see 98% oxygenation. There's the instrument. Here's the cable. And the thing that is going on the finger is the sensor. So this is what that is. This is the sensor component of the pulse oximeter, right? They'll come in a little sterile bag like this, and you would put it on someone's fingertip, and so it runs at a length, right? However, right, they don't have to be this way. The type of pulse oximeter you're probably much more familiar with is shown right here, right? This is a fingertip pulse oximeter. This one is on right now, and it's showing 98%. Right? I don't have to go to the hospital, right? So it's reading it. Given that you have this, why would you use this, right? This seems a little bit more convenient, right? There's no cable, right? It goes just like that, right? You talk the example of my son, right? Surely they didn't compromise, right, on his health care and on his monitoring. Why have a cable? Any ideas? Yes. Right. So the suggestion is that in hospitals, these devices are connected to other systems, such as an alert system, right? And so if the oxygen goes below a certain level, maybe an alarm might go off. That's one reason. Another reason is, again, the fact that maybe you want something sterile or clean to go on the fingertip, right? And so this may be a little bit harder to clean, maybe another reason. And there's many other practical reasons, right? I mean, you could say, well, but then couldn't this transmit wirelessly? Sure, right? But you're in a hospital setting, it's a critical care setting, and then what? The Wi-Fi goes down, right? And so there are many reasons why we want to stick to this kind of wired assembly. The other thing you could notice is that the thing that goes on the fingertip, right, is maybe pretty minimized, right? Just a little sticker with a cable coming off of it. So that means that we avoid having to have the equipment, right, and the display on it, right? So there's a practical aspect of it where you have the sensor in one location, and then the cable, and then the equipment, as big as it is, right, and it could be, in this case, it's small, but it might be larger, is somewhere else, right? There's also the fact that here the display is here, right? Whereas if this is in an operating room, right, people might want to see that in another display. And there are other reasons as well why, more often than not, this would be the default form factor. All right? Yes?
Is there a cost benefit to either having the display on the device or having the wire connected?
That's a great question. Is there a cost-benefit difference? I'm sure there is. I mean, in this case, you are selling possibly disposables. I'm guessing that this equipment is significantly more expensive than this piece of equipment. but how that factors into sort of the healthcare pipeline may depend on the use case. Okay. All right. So with that in mind, we can review again the basic parts of a biomedical device that's used for measurement. I put this up before, and I will be putting it up again and again. We talked about how there are many, many types of instruments, right, that do all kinds of measurement, right? But I also explained that the goal in this class is to explain to you general principles that would apply to all these instruments. And this very simple diagram is very powerful in that direction. It shows you that when you talk about a medical instrument, you must have a sensor, and you have some sort of circuit connected to it, and then you have a display. And between the sensor and the circuit is a wire, which is nothing, just two, in fact, two, and I've made a point of illustrating here as two cables, right? There's actually two wires typically inside the thing. And we can make this as long as we want. And so that generates a distance between the sensor and the circuit. Okay. Now, the characteristics of the sensor will govern what the whole instrument does. So if the sensor, it measures, for example, blood oxygenation level, right? It's a oximeter, right? Then the whole thing is an oximeter. And of course, the display would give you a reading of, you know, some measurement of how much oxygen is being carried in the blood. It starts with the sensor, and we'll understand that today. If the device is a temperature measurement device, then this is a temperature sensor. And of course, as a result of that, what's shown on the display, is the temperature of the body or in the room. And we talked about last time how we understand from almost any basic temperature meter, right, that the sensor is where the temperature is measured, right? That's why I wouldn't grab onto it here or here, but I would grab onto it here. So we'll need to understand what exactly that sensor is and how this process works. Okay.